Many PhD theses and research articles today are based on very large data sets, sometimes hundred or even thousands of observations, collecting using Likert scale type scales ranging from 1 to 5. Yet many such studies are rejected or questioned with the familiar comment: your data are Likert scale and not normally distributed. Therefore, parametric tests like ANOVA are invalid. This statement is still common, but modern statistical literature tells us clearly this is no longer a valid reason for rejection. In this presentation, we will separate statistical myths from established facts using authoritative references. The confusion arises mainly from two outdated assumptions. First, that Likert scale data are strictly ordinal and therefore cannot use means or parametric tests. Second, that parametric tests require perfectly normally distributed data. Both assumptions are debated decades ago and empirically resolved in statistical literature. Unfortunately, these debates are often forgotten in applied research evaluation. Myth 1: Likert data must always use non parametric tests. The myth states that because Likert scale responses are ordinal, tests such as Mann-Whitney or Kruskal-Wallis must always be used. The fact is, Carifio and Perla in Medical Education 2008 demonstrated that summated Likert scales formed by combining multiple items behave like interval data. Similarly, Norman in Advances in Health Sciences Education 2010 showed that parametric tests are robust and meaningful for Likert type data, especially when scales have five or more categories. Therefore, Likert does not automatically mean non parametric. Myth 2: non normal data invalidate ANOVA. This myth is often supported by statistically significant Shapiro Wilk test. The fact is, as Andy Field explains in Discovering Statistics Using SPSS, normality tests almost always reject normality in large samples, even when deviations are trivial and irrelevant. Tabachnick and Fidell, in using multivariate statistics, clearly state that ANOVA is robust to moderate and even substantial violations of normality, especially with large samples. What matters is not raw score normality, but the sampling distribution of means governed by the central limit theorem. This is basic and established statistics. Myth 3: non parametric tests are safer. Non parametric tests are often seen as safer alternative, but the fact is different. Simulation studies by Glass, Peckham, and Sanders as early as 1972 showed that ANOVA maintains appropriate type 1 error rates under non normality, especially as sample size increases. In contrast, non parametric tests have lower statistical power, provide less interpretable results, are not designed for large balanced designs. Modern methodology favors Welch ANOVA or robust techniques not a blind switch to Mann-Whitney tests. For large sample Likert scale based research, good statistical practice includes one-way ANOVA or Welch ANOVA, checking homogeneity of variances, not obsessing over normality, reporting effect sizes, transparent methodological justification, rejecting a study solely because parametric tests were used with large Likert data is not supported by statistical evidence. Statistics is not about following rituals, it is about robust inference based on evidence. The literature is unequivocal: large sample plus Likert scales plus parametric tests is acceptable, defensible, and standard practice. Methodology must evolve with evidence, not remain frozen in outdated rules. The video is for examiners, reviewers, and research scholars to clarify the myths and provide encouragement for further reading. Thanks for watching. Give your comments if you disagree with this. Thank you.
Always share the videos of Dr. Sachdeva to your friends who are interested in data analysis.